So if you just leave this talk with just one thing in mind, all of these things that I just mentioned, they're just adding time and difficulty to your hacker, right? To any hacker. So again, hackers with enough determination, money and time, they will be able to decompile and find what you're trying to hide. So pretty much you always need to have a threat model and develop your application with remediations necessary to accomplish the goals that you're trying to get. All right, so today we're going to talk about we're going to talk about Android security, and we're going to talk about how we can hide some more sensitive parts of our applications pretty much within plain sight. Let me begin with introducing myself. My name is George. I'm originally from Greece. I've been living in the UK for the past 5 or 6 years, and I'm working for Amazon. Currently, I'm within the Ring team, so if you use any Ring products and have an Android phone, you're probably running some of my code. And before that, I was within their Fire TV team, so I was handling some applications within their Fire televisions. And also, another thing that I want to mention is pretty much for me and for most of speakers coming here, it's a really big deal that all of you, of course, take time and money out of your schedule to come and see us. And for me, especially as a car guy, you taking the time to see me instead of the Ferraris is a huge deal. So thank you. Thank you very much. Okay, so let us begin. What exactly is inside an Android application? What exactly are we trying to hide? Of course, we have our source code. We have our resources. Resources can be the manifest, images, strings, anything pretty much that consists, that sits inside the resources folder. And of course, we have all of the extra modules, all of the libraries that our application might be implementing. Some of them might be open source, some of them might not. So pretty much the idea of this talk is that all of these things are not safe. All of these things pretty much sit inside the APK, the Android executable file, and this APK is open to everybody. So they can take the APK, they can play around with it, and they can do whatever they want with it. We're actually going to do that in a bit. But before we do that, let's discuss a little bit more about motivations behind it. Of course, why would somebody try to hack our applications? We're talking about stealing or leaking information to the public. We're talking about disruption of services, driven by purpose or hacktivism, which is a little bit higher up this time of days. And of course, hacking can be done for any financial gains. All of this sits under the black hat type of scenario, so pretty much this is the bad type of hacking. And then, of course, there's the white hat, which is the better type of hacking, which, of course, on those cases, many companies or many developers can actually open up bug bounties, which means that I'm making an application, or let's say something a little bit more realistic. Let's say a big company created an application, and they said, OK, anybody who is able to hack it, do it. Let us know how you did it. Let us know how to fix it, and then we'll pay you awesomely for that. So this is one good way for hacking. And then, of course, there's security audits, which is pretty much a whole sector of companies that you're paying, you as the developer, are paying, and pretty much you're giving them your application and tell them, hey, just find what's ever wrong with it, try to hack it, let me know how you did it, and then let me know how to fix it. All right, so in terms of today's agenda, we're going to split the talk in 2 parts. We're going to begin with the offense part, where we're actually going to take an APK, we're going to play around with it, we're going to try to find a couple of stuff that are hidden within the application, and then we're going to pass to the defense part, in which we will take various use cases and we will see what you can do in order to hide some parts of your application or some parts of your user base a little bit better. So let's begin with the offense. And before we actually start decompiling an application, we first need to see what the application consists of. So let's begin from the left. You as a developer creates an application, so you have your source code, of course, you have your assets, your resources, and your manifest. And then, of course, you have all of your libraries. So when you press build, what happens is that the first step is that the manifest, the resources, and the assets are bundled together. And they're bundled on what's called the AAPT packaged resources file. Then this packaged resources file and the source code, which got compiled into bytecode now, they get bundled again. And literally, when I say bundled, I mean they create a zip, and then they rename the zip into .apk. So there's nothing major happening there. But they are bundled together, and then we have an unsigned APK. And once we have an unsigned APK, we get our key, which is really important, and we're going to discuss more about the key later. And we're going to sign our APK. And once we have a signed APK, we're ready for production. We're ready to upload it to Play Store. We're ready to send it to any of our user base. All right, now let's go to the fun part. So I will open Android Studio, and I will focus on my emulator. So of course, we don't have a lot of time, so I create a really small example application that will enable us to play around a little bit. So this application consists of 2 pages. One page, you see there is an image, some text, and a button. And once we press next, we read a text that says, below is my secret key, but you cannot see it. So based on what the application tells us right now, something is happening on the bottom part of the screen, but we cannot see it. So what we're going to try to do now is going to try to find what is inside that bottom half of the screen and why we cannot see it. All right, so let's do it. You don't need any fancy equipment, any fancy tools. A couple of years back, when I did the same presentation, I used to use Terminal, and then I used to download some terminal tools. Now you don't need to do any of that. You just need Visual Studio Code, which is free, and then a single add-on called APK Lab. That's also free. So pretty much what I'm trying to tell you is that you don't need any fancy equipment, or you don't need to pay any money to actually have somebody do that for you. So I'm going to use APK Lab, and then I'm going to select this APK file. This is a production file, so this is a signed APK file. And pretty much I'm going to select to decompile Java, and just for the sake of time, I'm going to leave everything else like that, and I'm going to give it a couple of seconds. Just about now, it should be done. Cool, so let's close this extra folder, and let's focus on this folder. So once APK tool did its thing, it created a folder for us. That folder, of course, the same name as the application that we gave it. So once we started exploring that folder, we start to see a little bit some familiar stuff. So the first really familiar thing that we see is Android manifest. And that's exactly word to word, line to line, the Android manifest that I built for this application. And as we can see, we're using 2 activities. One activity is the launcher. There are no requirements. There are no permissions used in this application. So this manifest is literally word to word what the developer writes. And then let's close that. And before we go to the good stuff, which is the Java file, the Java folder, we're going to go into resources. And we're going to start having a look at the resources. Of course, quite a lot of stuff have been added here, quite a lot of stuff that the developers did not manually add, but the compilation process added. So if we open the animations folder, you're going to see quite a lot of Android animations. We're going to go into drawables, which, as you know, you saw me using a single image. So let's try to find it. Again, there are many Android drawables in here. But once I start scrolling around, I will see literally the same picture, full resolution, full everything that I used when building the application. But that's not too interesting. So let's go to the more interesting stuff. Let's close drawables. and go into layout, because in the end, this is what we actually wanted to find out. We want to find something in the layout. And again, a lot of layouts that were created by the Android OS during the compilation. But if we scroll and if we know where to look, we will find two layouts that look pretty interesting. There's activity main. And in activity main, as you can see, there's a linear layout with an image view, two text views, and a button. Exactly what you saw on the screen. This is literally what I wrote. And then there's the second activity, which is activity secret. And if we take a closer look to it, there's a linear layout with two text views. And the first linear layout, the first text view writes exactly that. Below is my secret key, but you cannot find it. And then we go into the second text view, and we read that this is a placeholder from a hidden message. So we're probably thinking that this is not what we were trying to hide. But if we take a closer look to it, we will find why it was hidden. And the reason is actually pretty simple. The background was white, the text color was white, and that's how we just could not see it. All right, so let's move forward. And let's open values. And in values, I'm going to open strings. And this is where things get a little bit more interesting. So I want you to focus pretty much on the first three strings. Those three strings are the strings that I created on my application. I hard-coded them. The two underscores, I just put in them so they can appear on the top, on the decompilation. Everything else is just Android-related stuff. And pretty much what I want you to see is that if any of you tries to hard code any sensitive information, so any keys, any codes, any passwords, anything remotely sensitive in your strings file, please don't. They are literally right there. There is no encryption, there is no obfuscation, there is nothing. They are available. So this is a big no. Please don't do it. And finishing up with resources, let's go into the Java folder and let's discuss about some other things that we should not be doing. So before I actually open Java folder, we see that there's a Kotlin folder, but there is, while I wrote the application in Kotlin, the Kotlin folder only contains some Java build and Kotlin build stuff. So in order to find our own or the app's own source code, we go into Java source, and again we will need to find the full path of our application. In my case, it was this one, super secret application. And we can see quite a lot of stuff. First of all, build config. If you had anything remotely sensitive in your build configuration, again, don't. You can see that literally everything's enumerated over there, so that's also not a safe place to hide something like that. We can see a file called constants. You know, I know that I've personally used a constants or a similar file like that on plenty of my projects. And you can see quite a lot of stuff. You can read that that was compiled from a constants.kt. That was an object file. But pretty much, if you start reading this Java file, you'll see that there are 3 variables with hard-coded strings, and then some getters. So this is just how Kotlin to Java build converts an object file. So again, 3 lines here, strings that got hard-coded into Kotlin. Everything's right there. I know it looks pretty bad right now. I know that the more you look at it, it doesn't seem it gets better, but this is the whole idea of it. You need to be aware of these security risks, and then you need to make sure that you develop against it. Anyway, so again, 3 pretty important variables. Let's see if they're used anywhere. We're going into main activity. We see that main activity has a couple of methods, get stuff from internet, nothing, literally exactly the way I wrote it. On create, a log, logs are also there without any difference whatsoever. And then we're having a button, we're setting an on-click listener, and the on-click listener starts a new intent, starts a new activity. And then we also have another method that encrypts something important, that you could search for something, some more keywords while you're doing something like that. So encrypt or decrypt might be a little more keywords during an operation like that. So let's dive down in that method, and what we can see is just that it takes a string and it reverses that string. So that's not exactly encryption. But it was something simple that I wanted to throw around. So let's move into secret activity. As we saw, secret activity was the layout that we opened before. Again, secret activity got compiled from a Kotlin file. That's why you take a look at a little bit more stuff. And inside secret activity, we find a text view. And then we set the text into the constants AWS secret key. So what's actually appearing on that screen in white is that. Okay? So that was a little bit, a small, quick game, a teaser, just so I can show you that any APK can be decompiled, and quite a lot of stuff are there for a lot of people. Now, in my test app, I also created a second module, apart from the app module, and that module, I just added a simple Kotlin file, and as you can see, the same thing happens. In that case, any extra modules that you bundle within your application are also visible. So yeah, this is actually the full extent of the things that you can find from an APK. Now, let's move back into the presentation. And let's reverse gears and let's go into defense. Now, in defense, I'm going to talk about plenty of use cases. Of course, some use cases you may not need them. Some use cases you might do. There is a variable difference in terms of how important those are. But again, those are small little changes that you can do in order to make the application a little bit harder for somebody to reach and hack. So first, in case you're using an application that has location, don't just display the user location, or don't just display, or don't take for truth, don't take for granted any sort of location that you receive from the operating systems. There are quite a lot of tools that can just spoof and mock that location. So, and it's super easy for an end user to mock that location, but it's also really easy for the developer to check if a location is being mocked. So there you find quite a lot of code samples on the internet, but the idea is that if you're dealing with location, please always check for mock locations before you just do anything with that. Next up, let's talk about HTTP responses. So this is actually quite an important one. I know that I've been in that situation quite a lot of times. And what I want to discuss about here is the whole idea of acting based on the HTTP responses. What do I mean by that? Usually, I'm having an HTTP response, and if I get a 200 response code, then I know that everything's fine. And then I have an else, do nothing, or cats, show a message. And maybe 90% of the times, that's fine. But maybe on that small percentage of 10% of the times, it's worth investigating what's happening wrong, and why this is happening. So if I get an unauthorized error, depending on the severity of the application that I'm having, I might need to implement a retry, a max retry, and then maybe even lock the application for a couple of seconds, minutes, hours, days, right? It's the same as somebody just trying to unlock your phone using various codes. They will be able to try maybe 10 times, and then they might be locked for a couple of seconds, then they might try again, then will be locked for a couple of minutes, so on, so on. Again, that's not for everybody. but sometimes that actually might be worth investigating. So always try to check what happened. Like when something happens wrong, try checking what happened and what you can do to mitigate that. All right, next up, local storage. Of course, almost all of the applications are using local storage, and local storage varies quite a lot. There are shared preferences, there are files, there are databases. So there are places to store various bits of information depending on the severity, again. So on the simplest and most plain way of storing data, we have shared preferences. Shared preferences is just a key value pair storing. It just gets stored into a simple file, and what do I mean by simple file? It's just a file that anybody within the file browser can find it in your application, open it. It's not, again, not obfuscated, not encrypted. So why it is there? Of course, it serves a purpose. You can save stuff, but you cannot save stuff that are sensitive. So if there's something simple, like, I don't know, the user's settings or the user's preferences, something that you don't really care if it gets read or changed, then shared preferences and external storage is, of course, the simplest and fastest way for you to do it. If we want to add a little extra security on that, Android also provides encrypted shared preferences. So encrypted shared preferences pretty much creates an encrypted file, so an ESP file, and that file gets encrypted with a master key. So this is actually when it is a bit better for you to store sensitive data. Of course, as a good rule of thumb, we should not be storing sensitive data, or we should try to avoid storing those types of data, but sometimes that's not possible, so if we do have to store them somewhere, encrypted shared preferences is a better way to do it. And of course, it's not that once we do instantiate an ESP file and an ESP variable, we don't just store everything there. We need to be more mindful of that. We need to split our application into use cases with different master keys. The reason behind that is if one master key is found public, then users and hackers will only have access to a specific portion of our data and not all of our data. We pretty much split our data across that. And how do we store the master key? Because, of course, the most well-secured door is as good as where its key is hidden, right? So if I have the best door, the most secure door in here, and I have the key in public, then it doesn't serve its purpose. So where do we store our keys? Android gives us the key store, which is it's a secure place that Android OS handles, so it's not up to us to handle, and that gives us a little bit more peace of mind. And pretty much this is a place to store all of our encryption keys, all of our master keys, so it's a place to pretty much have a safer portion of the device to store those types of data. Usually, we should, of course, always use the highest security level supported by operating system when we're using the key stores, and then there are, of course, some methods that are really good to be used, like the set unlock device required. So we always need to have the device unlocked and authenticated in order for the key store to be even accessed. So it cannot be accessed, for example, from a service while the phone is locked. But in general, if you're using a combination of those two things, you stand a better chance when trying to store sensitive data. Next up, let's talk about the NDK. So when we're creating Android applications, we're of course writing with Java and Kotlin, but we also have the option to go a level down and write native C bytecode. Write native C code that during the compilation, it gets compiled into native bytecode. So if you do need to hard code something, or even better, try to, instead of hard coding this key or this variable, try to build it dynamically using an algorithm. That would be even better. But if you absolutely need to store something like that in some hard-coded way, it is a little bit better to do it in the NDK. And why I'm saying that, it's not because the NDK is not hackable. It is exactly the same. I didn't have it on my example, but once you decompile the Android application, you can just get the the native bytecode, the NDK bytecode, and then you can decompile that. It's just that decompiling C is a little bit more hard, and it's also an extra step added to an extra step added for any of the hackers. So pretty much while it can be decompiled and while it's not something unbreakable, if you absolutely have to hardcode something, it is a little bit better to go this way instead of hardcoding things like are hardcoded in Java, like we saw before. Okay, let's move forward. Let's talk about the APK signature check. This actually does not get the credits it deserves because this is a really important part of building and publishing an Android application. So as we spoke before, I told you that when we're building an application, we have, of course, all of our source code, the resources that get bundled, and then they create the unsigned APK. And then we have a key. That key is the only part of the Android application that remains within your reach. That means that that key does not go into the Android application and does not go into the hands of the hackers. So that key needs to be remained and stored safely within your reach. So when we're storing an application, when we're signing an application, the application gets that key and then it has the hash of that key that got signed. So anytime the key runs, anytime the Android application runs, we can check what is the key that is signed, that was used to sign the application that's running right now. So if we know the key that signed the application running right now, and we safely have the hash of the key that we know that only we own, if we compare those things, we can make sure that the application running on the device is the application that we developed and signed. Why? What is the difference? What's the difference? What can happen in other terms? A hacker can take your application, like we did. They can decompile it. They can change something, and then they can recompile it back. So far, so good. But the thing is that before they send this application to the users, they need to sign it with something. And when they will sign it with something, since they don't have your own key, they will need to generate their own, sign it, and then ship it. So having a check like that, you can make sure that the Android application running is always signed with your own key, which again pretty much tells you that this application has not been modified whatsoever. And last but not least, if you have any supercritical algorithm, something that differentiates you, any sort of thing that you don't want other people to know, just close it behind an API. Like your backend is way more secured. You have, meaning that you have more access on who can hit that API, from where, how many times. It's not something that just goes live and bundled within your application. So if you have something that you absolutely don't want anybody to have in their hand, just close it behind your own API. Okay, so those were the use cases I wanted to discuss, and pretty much before I close, I want to discuss again about everything that I just said so far right here relies on a secure operating system. So, of course, as we all know, Android operating system can be rooted, and once it gets rooted, developers and hackers can get their hands on as low as they want and as low as they can. So that means pretty much that any of those security mitigations that we discussed so far, even if you implement them all, on a rooted, when the application runs on a rooted device, all of this can mean nothing because it can be changed on a lower level. So if you just leave this talk with just one thing in mind, all of these things that I just mentioned, they're just adding time and difficulty to your hacker, right? To any hacker. So again, hackers with enough determination, money, and time, they will be able to decompile and find what you're trying to hide. So pretty much you always need to have a threat model and develop your application with remediations necessary to accomplish the goals that you're trying to get. Yep, and that was it. Any questions? Thank you.